as we talk about our solar system, I want to begin with the discussion of the nebular hypothesis. Around 1800, there was an astronomer called Laplace. And Laplace developed this theory, the nebular hypothesis. And it's the leading theory in explaining how our solar system developed. It begins with the reflection nebula, which you see here. And that nebula collapses. And as it collapses, the collapse is not even on all sides, as you might expect. And so it creates a rotation. And as it continues to collapse, the rotation increases more and more, and eventually, as this mass begins to rotate, it will extend out into a disk shape, which begins to create the shape of our solar system. The debris in the nebula is still circling around the proto-sun in the middle, and eventually that debris will begin to collect into gravitational areas that become the planets. So this is a diagram that shows what the initial phase of planet formation may have looked like. In Laplace's nebular hypothesis, it begins to spin. As it spins, it flattens out into a disk. That's just due to the conservation of angular momentum along the area of highest velocity. If you imagine a hippopotamus, very overweight hippopotamus on ice skates, skating around the ice, and then they skate to center ice, and they go into one of those spins. And you imagine the tissues of the hippopotamus as it's spinning faster and faster. It's going to flatten out, isn't it? Well, that's what's happening in the early solar system. So imagine this is a very overweight hippopotamus spinning and flattening out, just obeying the laws of nature. Eventually, gravitational centers will form in that mass, and the material will begin to be pulled toward that object. These are what are called protoplanets. So you begin to form these protoplanets, and they act sort of like gravitational vacuum cleaners. And the gravitational field begins to pull in more debris. So eventually you see something like this. This is a protoplanet. It's pulling in material, sort of sweeping up. Its gravitational field is sweeping up debris. Any objects that are moving too fast would spin out into space. Any objects moving too slow would be pulled into the sun itself. But those objects that are moving at just the right speed to create a stable orbit would remain, and that creates the series of planets that we see around our sun. And they're all within that initial plane that was formed by the spinning effect. And even today, when you recognize the planets in the night sky, Mercury, Venus, Mars, Saturn, Jupiter, you can see that they all form in a line. That's what they call the plane of the ecliptic. That's that original plane of the disk that formed. It's tilted across the night sky because our Earth is tilted, right? It's not that they're tilted, but we're tilted. So that creates a diagonal.